Hello viewers, welcome back to my channel Experience Physics. So this class we will be seeing the topic combinations of resistor. In the given network, how the different or various resistance are combined and a single equivalent resultant resistance is formed. Right. So basically only two formulas we are going to use to understand the topic combination of resistors. This is one of the important topics under the chapter current electricity of class 12 physics, right? These two formulas, number one, resistances in series what is the formula? Number two, resistances in parallel. Only these two formulas are enough for us to solve the number of problems in this topic, right? So for resistances in series, assume I have three resistances R1, R2, R3. Let me label them. The equivalent value, say these are two terminals AB. The equivalent value between the two terminals is RAB is equal to, you just add them, R1 plus R2 plus R3. See, you know the formula right from class 10, you are studying this formula, so I am not going to prove the formula for it. Similarly, if three resistors are in parallel between two terminals A and B, again let me write them as R1, R2, R3. The equivalent resistance between the two terminals A and B is, it is not equivalent, 1 by RAB, 1 by R1 plus 1 by R2 plus 1 by R3. That's all. Then we have to take again the inverse to find RAB. From here we will see what RAB is. So only these two formulas are enough, right? But some tips and tricks, ideas, concept we will be discussing whenever there is a need arises when we go and solve the problems, right? So here the tip number one is, in series circuit the current is same. So this is the fundamental concept. In series circuit the current will be same. In parallel circuit the voltage will be same. So different current will be flowing in the parallel circuit. So here the current is divided as I1, I2, I3, different current, right? Then again they are joining here. The total current we will get again here. Here the voltage is divided, V1, V2, V3. If there is a voltage source here, it will send one current, so the voltages are divided, right? Sometimes in a network, it will be a bit difficult in its first sight to find which are the resistances are connected in series or in parallel. In this case, you trace the direction of the current. You just flow of current, you trace it. So which part of the circuit are resistances carrying same current? If the flow of current is same in the two or three resistors, then it is series. Different currents are flowing with common junction, this is junction, common junction, then it is a parallel one, right? Okay, if the resistors are equal values, for equal values, say R plus R plus R, in series connection the equivalent value will be 3R. Let me draw the diagram this way. R, the two ends are A and B. So this is 3R. If there are n resistors, so R equivalent is equal to n into R. If there are 3 resistors, 3 into R. If there are n resistors, then it is n into R. Similarly, for parallel connection, if three R's are same value, R, if they are in parallel, then the equivalent value will be R equivalent or RAB will be R by N. If you work out it, you will get R by N, right? Here in this case, R by 3. If N resistors, if 3 resistors, then it is R by 3. If it is N resistors, then it is R by N, right? So this is multiplication R into N, this is R by N. For parallel circuit, the values will be reduced. In series circuit, the values will be increased, right? This formula will be very, very useful. This relationship will be very, very useful when we go and solve the problems, right? Okay. Then some tips we will be using. Anywhere you can put tips or tricks or shortcuts. The point number 1, tracing the flow of current. As I said earlier, you trace the flow of current. The same current flows through some resistances, then they are in series. If the current is divided and joined, right? If it is divided and joined, it is parallel circuit. So trace the flow of current, right? In some cases, the battery will not be given. In the circuit, you won't be given any battery, right? The source, right? In this case, how will you do it? Connect a dummy battery and trace the flow of current. If there is no battery is connected in the circuit, just resistance are given and you are asked to find the equivalent resistance only. In this case, you can connect a dummy battery and you can trace the flow of current, right? Then another tip which will be much used, redrawing the circuit. The circuit can be redrawn, right? In its appearance, for the first appearance, it may be a bit difficult for us to ascertain which are series or which are in parallel. So in this case, if we redraw it, it will be easy to solve, right? Redraw in the case means 2 points which are very useful. Look for short circuit. Look for any short circuit is there, right? Short circuit is a bypass. Bypass for what? Bypass for the current. For example, there is one circuit where in the part of the circuit some resistors are available, some current is coming from here, and one short circuit is available, then some resistance are available. This is say 2 ohms, 1 ohms, 4 ohms, 6 ohms. Here there may be some current. Assume 10 ampere is flowing from here and it is returning this way. Say this is 1 EMF battery, right? So 2 ohms, 1 ohms, 2 ohms, 1 ohms, 4 ohms, right? If a short circuit is available, the short circuit is a bypass for the current. The whole 10 amperes will be flowing through the short circuit only. The entire 10 ampere will be circulating in this bypass, in this short circuit. This is what I have mentioned. Short circuit is a bypass. No current, 0 ampere, 0, 0, 0. No current flows through it, right? So this is one important point. Short circuit is a bypass, right? In this case, the equivalent circuit is very simple, right? We can remove all the parallel connected resistance. Right? Short circuit is a junction. You look for short circuit. Short circuit is a junction. So here we are having some problems. We will be coming to know, right, what is junction and how the short circuit is replaced by a junction, right? So look for any short circuit is available, right? You can replace it with a bypass, you can consider it as a bypass, or you can replace it as a junction. This is one important idea, redrawing the circuit. Number 4, look for Wheatstone bridge arrangement. Wheatstone bridge arrangement. You just look for, right? How to find whether it is a Wheatstone bridge or not? The condition is it must have 4 nodes, 5 resistances. If it has 4 nodes and 5 resistances, this is called Wheatstone bridge, right? I can draw one such Wheatstone bridge here. Yes, this is one Wheatstone bridge. We are having few problems in our video, right? This is one Wheatstone bridge. A is one node, B is another node, C is another node, D is another node. Node or junction, right? So actually 4 nodes or 4 junctions. 1, 2, 3, 4, 4 junction, 5 resistances. So it is a Wheatstone bridge. Then we have to find whether it is a balanced one or unbalanced one. This condition, find whether that it satisfies us the balanced condition, right? Accordingly, the problem will be solved. So these are some of the ideas or tips. They are very, very useful for us when we go and solve the problems, right? So I will be discussing them whenever there is a need for them to use here, right? Right. This is problem number 1. What will be the equivalent resistance between points A and D? Right. So 1, 2, 3, 4, 5, 6, 7, 8 resistors are given in this problem between A and D. Between A and D, the equivalent value of resistors. Here, this 10 and 10, they are not in series. This 10 and 10, they are not in parallel. Similarly, this 10 and 10, neither series nor parallel. Neither series nor parallel. Neither series nor parallel. Right? That is the case in all the resistors. Right? I am not seeing any 2 resistors which are in series or in parallel in the given circuit if I look at it with raw eyes. Right? I am going to use one trick, right? What is the trick? Assume a battery is connected between A and D. So because across A and D, the question is to find the resistance. It will send one current I. If there is one battery, dummy battery, right? This is a dummy battery, imaginary battery. Then I am tracing the current direction it enters I, after traveling through the circuit, it leaves D because it has to return to its own battery. It enters 10 ohms. Here it meets one junction, then it is divided as two currents, I1 and I2. I1 comes down, it won't go there. It won't travel through this 10 ohm resistor because C is an open circuit. The entire I1 will be traveling through this 10 ohms. Similarly, I2, through B it won't flow. Through this 10 ohms, it will not reach B because it is an open circuit. All the currents I2, the value of I2, it is coming down. Then in this junction, I1 and I2 are added. It is divided here. Then here it is added. It is returning back to the battery. Right. So this resistor is not at all included in our calculation. It is technically absent. So then after removing these two resistors, if you see it, this is I ampere, through this first 10 ohms, I ampere is flowing, then I1 and I2, it is divided, right? This is the circuit. This is A and this is D. 10 ohms, 10 ohms, 10 ohms, 10 ohms, 10 ohms. Here it is divided, right? These two carries I2 amperes. So they are in series. These two carries I1 ampere, same current. So these two are in series. I1 ampere, same current flows through the circuit. This is the idea. If the same current flows through the circuit, it is series one. In a series circuit, same current. In the parallel circuit, different current flows. So similarly, these two are in series, different currents. So this is one branch and this is another branch. So they are in parallel. So 10 plus 10, 20, 10 plus 10, 20. Look at this circuit. Here it is 20, here it is 20. 20 and 20 are coming, 20 ohms are coming in parallel. So the resultant will be, for this circuit, it is 10 ohms. 10 plus 10 plus 10, 30 ohms is the answer, simple. So here you have to assume one battery is connected. Across which two terminals the question is asked. Right. A and D means you must assume through A current enters, through D it leaves. Right. That is the idea. Right. What will be the answer if RAB is asked? In this problem, it is 30 ohms. Okay, it is over. If the question is, instead of A and D, what is RAB? RAB. So you will assume a battery is connected between A and B. A current enters A and leaves B. The current is dividing as I1 and I2. I1 comes down, it won't go there because C is open circuit. I1 flows. Again, it will not go through this 10 ohm resistor because it is an open circuit. All the I1 will go towards this 10 ohm resistor. I1 and I1 and I1. So I1 is flowing through these three resistors. So these three will be series, 30 ohms. 30 ohms. Here I2. So I1 and I2, two different currents. So I2, this is I1. These two are in parallel. 30 into 10 divided by 30 plus 10. So I am using the formula R equivalent for two resistors. This will be much more useful. Instead of writing 1 by R equivalent is equal to 1 by R1 plus 1 by R2, we can use this formula also if there are two resistors, right? So this is 30 ohms, this is 10 ohms. 30 into 10 divided by 30 plus 10 will be the combination of this part. Then this plus 10, this plus 10, 20 plus, this is the answer. If RAB is asked, instead of RAD, if RAB is asked, right? You connect a battery between A and B. Similarly, if you connect a battery between A and C, if you trace the current directions, you will calculate what is the equivalent resistance value between A and C. Any two terminals, you can do it. Next, three resistors each of 1 ohm are joined in parallel. 1 ohm, 1 ohm, 1 ohm. They are joined in parallel. Three such combination. So this is one combination, right? One combination. Three such combination are put in series. 1 ohm, 1 ohm, 1 ohm, 1 ohm, 1 ohm, 1 ohm. Then the effective resistance will be, what is the effective resistance? So equal value of resistor, we have found equal value of resistors R by N. N is equal to 3 resistors. So this is 1 by 3. For series, we will add 1 by 3 plus 1 by 3 plus 1 by 3. 1 is the answer, option C. How many minimum number of 2 ohm resistors can be connected to have effective resistance of 1.5 ohms? See, if we connect two resistors in series, their value will be increased. If we connect two resistors in parallel, for example, I am connecting 2 and 4 ohms. 2 and 4 ohms connected in parallel. 8 by 6, 4 by 3, that is 1.33 ohms. Lesser than the minimum resistors. I am connecting 2 and 3 in 2 plus 4, yes, 6. I am having 2 ohms and 4 ohms in my hand. I am connecting them in series. 6 is the answer. Greater than the biggest value. Greater than the biggest value. 2 and 4 now I am doing in parallel. It is 8 by 6, 4 by 3, 1.33. Lesser than the smaller. Lesser than the smaller resistance. Right? How many minimum number of 2 ohm resistors can be connected to have effective resistance of 1.5 ohms? We have 2 ohm resistors. 1.5 ohm we have to make. I don't have 1.5 ohms, but in my circuit I want to connect 1.5, but in my table I am having a lot of 2 ohm resistors, right? So how to make it? 2 ohms, 1.5 ohms. So to make the value lesser than the original value, you have to make them in parallel, right? 2 ohm resistor, 2 ohm resistor. 2 and 2, when they are put in parallel, 1 ohm will be the result. But we need 1.5 ohms. 1 ohm resistor and 1 ohm resistor are connected in parallel. We will get 0.5 ohms, 1 by 2, 0.5. This is what we will be doing. 2, 2, 2, 2. So this is 2 by 4 is equal to 1 by 2 ohms. This is 2 by 2 is equal to 1 by 1 ohms. How many resistors are required? 6 resistors are required. Option C. If you have 6 resistors, you can make 2 ohm, 1.5 ohms value using the 2 ohm value. In the circuit shown below, what is the value of unknown resistance so that the total resistance of the circuit between points P and Q is also equal to R, right? What is the value of unknown resistor? This value is in question. So that the total resistance of the circuit between points P and Q is also equal to R. That is, R PQ must also be the value of this R. This is unknown resistance. The answer should be also equal to the unknown resistance value. How to find it? Right. So if you trace the circuit, these two are in series. For the series combination, 10 ohm comes parallel, and this part is becoming a single resistance. For that single resistance, the 3 ohm is coming in series, right? In equation wise, if you write it, First, we will make 3 and R in series. 3 plus R. This is in series. Then it is coming parallel with 10 ohms. Symbol for parallel 10 ohms. Then the square bracket is this part. Now this part is over. 3 plus R parallel with 10. Then this is coming in series with these 3 ohms. This is RPQ. This must be R. This RPQ must be R. Series, then it is parallel, then if you add it 3 is equal to R. If you work out, if you solve this equation, you will get the result. 3 plus R, 10, 3, right? Let me do it in a separate page. RPQ is equal to R is equal to 3 plus R parallel with 10. 3 plus R in parallel with 10. Then this combination is coming in series with another 3. This is again R, left hand side. So this is 3 plus R into 10 divided by 3 plus R plus 10 plus 3. This is 30 plus 10R divided by 13 plus R plus 3. This side R. Okay. This is plus 3. So 30 plus 10R plus 3 into 13, 39 plus 3R divided by 13 plus R. 30 plus 39, 69 plus 13R divided by 13 plus R. So if we cross multiply it, 13R plus R square is equal to 69 plus 13R. Both sides 13R we can remove. R square is 69. So R is equal to root 69 ohms. Root 69 is the answer. 3 ohms, option C. Root 69 ohms. Next, the effective resistance of 3 conductors in parallel is 60 by 47 ohms. When one of the wire is broken, the effective resistance becomes 15 by 8. First it is 60 by 47. It is 60. When 3 resistors are in parallel. When 2 resistors are in parallel, it is coming down to 15.8 ohms. The resistance of the broken wire is what? Yes. For 3 resistor, we will find the R equivalent. To mean it is 3, I am doing it. I am taking the 3 inside the bracket. So this is 1 by R1 plus 1 by R2 plus 1 by R3. The equivalent value is 60 by 47, but we are taking the reciprocal 1 by R equivalent. So I must write 47 by 60. Here it is 2 resistors. So 1 by R equivalent of 2. 2 mean they are 2 resistors. 1 by R1 plus 1 by R2 is equal to again reciprocal 8 by 15. So 1 by R1 plus 1 by R2 is some value 8 by 15. Let us put it here. This value is substituted here. 1 by R1 plus 1 by R2 is 8 by 15 plus 1 by R3 is equal to 47 by 60. Here we have broken one wire. The wire has become open circuit. So only 2 resistors are available. That is the reason why we have not written the R3 here. The question is to find the value of R3 only, right? Now I think we can easily solve it. 1 by R3 is equal to 47 by 60 minus 8 by 15. So this is taking 60 LCM, 47 minus 32. It is 15 by 60. So we need R3. R3 we need 60 by 15. That is 4 ohms. So the broken wire is having the resistance of 4 ohms. Option B is the answer. 3 conductors draw respectively the currents 1 ampere, 2 ampere, 4 ampere when connected in turn across a battery. If they are connected in series across the same battery, the current drawn will be what? 3 conductors draw respectively the currents 1 ampere, 2 ampere, 4 ampere connected in turn. First we are connecting one conductor, we are measuring the current. Second conductor, we are measuring the current. Third conductor, we are measuring the current, same battery. Current values are measured. Then all the 3 conductors, we are connecting them in series across the same battery. The current drawn will be what? So first, we will have the common battery V volts. First conductor, its resistance, let me draw. First conductor R1. What is the current it is taking? 1 ampere. Second conductor R2. It is taking 2 ampere. Third conductor, same battery, V volts in turn. So they are connected in turn. So V volts R3. Here it is 4 amperes. For third conductor 4 amperes. So according to Ohm's law, R is equal to V by R. V is V. R is equal to V by I. I is equal to 1. Here it is V divided by 2. Here it is V divided by 4. So now the resistance values in terms of voltages are available. Same battery. Now all the 3 conductors, their resistance, they are put in series across the same battery. We have not changed the value of the battery V. So first conductor R1, this is V by 1, this is V by 2 R value, this is V by 4. What is this current? When they are in series, we will add R1 plus R2 plus R3, that is the result, right? So I is equal to V divided by R equivalent. This current is in question. If they are connected in series, the current drawn will be what? This is in question. I is equal to V divided by R equivalent. V divided by V by 1 plus V by 2 plus V by 4. This is V divided by V of 1 by 2 plus 1 by 1 plus 1 by 2 plus 1 by 4. V we can cancel out. This is 1 divided by, if we take LCM as 4, 4 plus 2 plus 1. So this is 4 divided by 7. The current is 7. This 4 will go up 4 by 7 amperes. 2 by 7, 4 by 7. Option C is the answer. Right. Next question. In the following circuit, each resistance is of 9 ohms. 9 ohms. Yes, all are 9 ohms. The reading of ideal ammeter. Look at the word ideal ammeter. Ideal ammeter means it doesn't have any internal resistance. So this is a short circuit. For ideal resistance, you can draw a short circuit through it. You can remove the ammeter and draw a short circuit. So this current, the ammeter will read this current. Actually, the question is, reading of the ammeter means what is the current flowing through this line? This part, what is the current? This part, between this part, what is the current? That is the question, right? So 9 ohms, all are having equal values. The battery will also be 9. So all are connected in parallel. First part, 4 resistors, then they are connecting one ammeter, then another 5 resistors. So this current I can easily calculate. Parallel circuit, V divided by R, 9 by 9, 1 ampere. Similarly, this is also 1 ampere, 1 ampere, 1 ampere. All the branches are carrying equal values of current, 1 ampere. Then this current is flowing through all the resistors and it is returning back here. 1 ampere, 1 ampere, 1 ampere, 1 ampere, 1 ampere. All them are added here, 5 amperes. Then they are returning here, 5 amperes. Then this will be 4 amperes, right? It is not in question. Actually, what is the value of current which is flowing through the ammeter? The ammeter is connected in this part only through this line. 5 ampere is flowing. 5 ampere, option A is the answer. The effective resistance between A and B is what? Each resistance is 16 ohms. All the resistors are having 16, right? The circuit may look to be having a lot of resistances, but it is very easy. Within 30 seconds, you can solve the problem. Such a easy problem. 16. 4 resistors are connected. 16 by 4 is equal to 4. So this part is having only 4 ohms, the equivalent value. Similarly, this part 4 ohms, 4 ohms, 4 ohms. Between A and B, what is the question? So the equivalent value will be, if you redraw the circuit, it will look like this one. A and B, right? 4 plus 4 plus 4. If you assume one current is entering and leaving B, entering A and leaving B, this is I1 and this is I2. I1 is flowing through all the 3 4s. So they are in series. I2 is flowing through the bottom 4 only, right? Then this is parallel. These are in series, 12 ohms between A and B. This is the bottom resistance, 4 into 12 divided by 4 plus 12. 4 into 12 divided by 16. So in such calculation, do not make it as a big number. Don't write it is 4 and 12, 48, don't write, right? 4 into 12 is okay, right? Easily we can remove. 4 into 4, 16. Then this is 3. The answer is 3. Right. Figure below shows a network of resistance. The effective resistance between points A and B of the network is what? Between A and B. Right. Easily you can do it. So simplification. Gradually, if you make step by step simplification, you will arrive at the answer quickly. This problem is also a 1 minute problem. 3 plus 3, 6 ohms. See, between A and E, they are in series. 3 plus 3, 6. The 6 is coming in parallel with this 6. 6 into 6, equal value. So this will be giving 3. 3 plus 3, 6. 6 parallel with 6. 6 parallel with 6 is equal to 3. Then this 3 will come in series. 3 plus 3, 6. 3. 3 plus 3, 6. 3. 3 plus 3 parallel with another 3. That means the last part A, B, 3, 3 and 3. This 3 is from here up to this part. Up to this part 3 ohms. The green line. Then this 3 ohms. This is B and this is A. 6 into 3, the answer is 6 into 3 divided by 3 plus 6 is 9. So 18 by 9 is equal to 2. 2 ohm is the answer, option D. The equivalent resistance between points A and B is, right? A and B, between D and E, this is the important point. Between D and E, a short circuit is. So whenever you find a short circuit is a bypass. This is one tip. You can remember it always. Short circuit is a bypass. That means if you connect one dummy battery across A and B, a current enters, it flows bypass, right? Then it will return. It won't go through this part, right? It is proven easily. What is the equivalent between A and B? I am taking one example circuit A and B. This is R ohms. Across this R ohms, there is a short circuit. What is the equivalent value? It is not R. 0 ohm is the answer. RAB is equal to 0 ohms. Why? This is considered as 0 ohms. Always short circuit is considered as 0 ohms, right? Practically there is no wire is available in the market which is having 0 ohms, but our calculation we can consider it as 0 ohms, right? For parallel circuit, R1, R2 divided by R1 plus R2, R1, R2 divided by R1 plus R2, R into 0 divided by R plus 0 will be the answer 0. So if you make one short circuit across a resistor, 0 will be the answer. So this is 2R plus 2R, 4R. 4R are coming across this DE, this is a short circuit. Across this short circuit, 4R are coming, so 0 is the answer. So this will not present technically, only it is present physically, right? So all the current will flow through DE only, this path only. Then what is the answer? R plus R, 2R is the result. Right. It is one interesting problem, but we can easily solve it. I will give you one tip here. 12 resistors of each 12 ohms. All are having 12 ohms. Connected in the form of a cube. The effective resistance of the system across the diagonal opposite corners AB. Diagonal opposite corners is what? 10, 20, 30, 40. Right. In such problems, so simplification of all the resistors, if we consider them, it will be a big exercise. It is also a futile exercise, waste exercise, right? One idea. Already I have told you, connect a dummy battery. Then trace the circuit. Between A and B is the question. So between A and B, connect a dummy battery. Assume some current is delivered from the battery. It is one junction. The current has to divide. I am writing their values as, actually it is 3 paths are available at this junction. I am writing I by 3, I by 3, I by 3. Equally it is dividing. You may ask me, how it is divided equally? Why can't it be I by 2? Why can't it be I by 4? Why can't it be I? Right? I will tell. Equally it is divided. The reason is, take any path and count how many resistors it is crossing before reaching B. Take this path, one resistor, second resistor, third resistor, right? If you take another path, this path, one resistance, second resistance, third resistance. If you take another path, one resistor, second resistor, third resistor. right? I am taking another path, first resistance, second resistance, third resistance, right? Let us take this path also, first resistor, second resistor, third resistor, first resistor, second resistor, third resistor. All the currents, if they want to go to B, they have to cross only 3 resistors, right? The tendency of current is always it takes the shortest path. 3 resistors it has to cross, right? So, in all the paths, only 3 resistors or equal number of resistors are going to be crossed by all the electrons. That is why I am dividing the entire current equally. I by 3, only 3 paths. Only 3 paths. I by 3, I by 3, I by 3, right? Then let us take only one path. There are a lot of paths. In fact, I think 6 paths are available. Only one path we will take and we will apply Kirchhoff's voltage law, right? Because this is the current I, this is battery V. The equivalent circuit will be, the equivalent value of this cube will be R equivalent, this is V, this is I. R equivalent will be V by I, or V is equal to I into R cube, or equivalent. This concept I am going to use. I am going to trace only one circuit. Let me draw with green line. Yes. This circuit I am going to trace. I by 3 is the current here. Then the drop will be equal value. Let us say this is R ohms. Then finally, let us substitute R is equal to 12. First assume R. I by 3 into R. That is the drop here. Ohm's law, IR. I by 3 into R. This I by 3, this current I by 3 comes here. Then it is equally divided as I by 6 and I by 6. I by 3 is 2. It is finding 2 branches, equally it is divided. So this will be the drop here will be I by 6 into R in the second resistors. Similarly, drop across this resistor I need, for that I need what is the current through it. This is I by 3, here it is divided as I by 6 and I by 6. I by 6 and I by 6. This is I by 6. One I by 6 is coming from top, I by 6 plus I by 6. It is added here. I by 6 and I by 6 added I by 3. I by 3 into R will be the drop. I by 3 R, I by 6 R, I by 3 R. The entire circuit, in the entire circuit, if you write Kirchhoff's voltage law, the total voltage, the applied voltage will be equal to the sum of all voltage drops. So V is equal to I by 3 R, first voltage drop, second voltage drop, I by 6 R plus third voltage drop, I by 3 R. This V I am going to replace it with I into R equivalent. I into R equivalent. So IR 1 by 3 plus 1 by 6 plus 1 by 3. I we can take R equivalent is equal to R of 6 as LCM, 2 plus 1 plus 2. So this is 5 by 6 R equivalent. R equivalent is equal to R value, it is given as 12 ohms. So 5 by 6 into 12, 2. So 10 ohm is the answer. This cube, the equivalent resistance value of this entire cube is just 10 ohms. So the tip is connect one battery, assume one battery which is connected between A and B and trace the circuit, right? That is the tip here. In the given network, the equivalent resistance between A and B is what? or AB is what? 4 and 6, they are neither series nor parallel. 3 and 12, they are neither series nor parallel. Similarly, 6 and 12, no, they are not series, not parallel. Right? So, in this circuit, if you look at this circuit, you can't say or you can't find any two resistors which are connected in series or in parallel. So, we have to redraw this circuit. That is the idea. The trick is, already I have told you, short circuit is a bypass. Another trick is, short circuit is a junction. This is the trick we are going to use and we will redraw it. Short circuit is a bypass. A couple of problems back we have used that concept. Short circuit is a bypass, right? Here short circuit is a junction. What is a short circuit? This is a short circuit. You can use these two ideas in any number of problems wherever it is required. Right? Short circuit is a junction, right? So this line is a junction. B is a junction, A is a junction, this line is a junction. Let me label it as C. Then we will redraw it. B and C 4 ohms, A and C 6 ohms, B and C 12 ohms, A and C 3 ohms. 3 nodes you draw it. A, B, let me take C here. Between B and C 4 ohms. So this is one node. Between nodes B and C 4 ohm is connected. B and C 4 ohm is connected. Then the 6 ohms. A and C 6 ohm is connected. Then this 12 ohms. It is connected between B and C. B and C 12 ohm is connected. A and C 3 ohm is connected. Yes. Now it looks simple. Between A and B, the question is, what is the equivalent value between A and B? 6 and 3 are in parallel, 12 and 4 are in parallel. It will give you one single resistance, then between A and B, these two are in series. Right? So for parallel, 3 into 6 divided by 3 plus 6. 3 into 6 divided by 3 plus 6. 12 divided by, 18 by 9 is equal to 2 ohms. For here, 12 into 4 divided by 12 plus 4. 48 by 16 is equal to 3. So these 3 and 2 are in series. Left hand side it is 2 ohms. A, B, 2 and 3 series. 5 ohm is the answer, option D. So the trick is, use short circuit is a junction. In that problem we use the trick short circuit is a bypass. Right? The equivalent resistance between A and B in the given network is, once again, if you redraw this circuit, you will easily solve it. This is your common junction. Let us name it as C. Between A and C, between A and C, between B and C, between B and C, redraw it. Then A and B, A and B. So there are 3 nodes. C, A, B. First let me take 8 ohms. 8 ohms. This is over. Then A and C 2 ohms. This is also over. B and C 4 and 6. 4 and 6. They are also over. Then A and B 6, A and B 3. 6. Again between A and B 3. Now it looks simple. These two are having common nodes A and C. These two are having common nodes B and C. These two are having common nodes A and B. So this is 8 into 2 divided by 8 plus 2. 16 by 10, 1.6. This is 4 into 6 divided by 4 plus 6. 24 by 10, 2.4. This is 3 into 8. 3 into 6 divided by 3 plus 6. 18 by 9 is 2. Again we will redraw it. A, C and this is B. The question is between A and B only, right? A, B, 1.6, 2.4 and this will be 2. Now A and B is in question. So if a current enters A and leaves B, it will flow through 1.6 and 2.4. Same current flows through 1.6 and 2.4. So these two are in series. Through it, different current. It is assume it is I amperes. This is I1 and this is I2. I2 is flowing through these two resistors. I1 is flowing through 2 ohms only. So this is coming in parallel with these 2 ohms. 1.6 plus 2.4, 4 into 2 divided by 4 plus 2. 8 by 6 is the answer. That is 4 by 3. 4 by 3 option A. So the trick is, if you redraw this circuit, you will get the idea quickly and you can do it very fast. The resistance between P and Q in the circuit shown is what? P and Q. Right? So it is not open circuit. This is not open end. Earth symbol. So at the two ends, it is grounded. It is grounded. That means we have studied earth is also a conductor. This way it is closed. Right? This way it is closed. Again we have to redraw it. If we redraw this circuit, we will easily find the value of RPQ. That is in the question. Between P and Q or between P and Q or P and Q. First let me draw the two nodes R and R. These values I have taken. Between P, this R, then through the same line it is another R and it reaches Q. Actually this is nothing but two resistors which are in series, R plus R. So between P and Q, R, 2R. 3 resistors are available. So 1 by R equivalent is equal to 1 by R plus 1 by R plus 1 by 2R. 2R, take it as LCM. 2 plus 1, 5 divided by 2R. Then R equivalent is equal to 2 by 5 R. 2 by 5 R is the answer. Yes, option B. The equivalent resistance between point P and Q in the figure is approximately what? Right. P and Q. Again we will use the trick. Short circuit is a node or junction. Short circuit is a node or junction. Both are same words. Node or junction. Let me name it as C. Common node or common junction. Right. So this is P. Between this point and this point, a short circuit. So that means I can also write P here. This point and this point also same. I can also write P here. That is the idea. Similarly, this point and this point, a short circuit is available. Only wire is available. No component is available. In this part, no component, resistor or anything else. Right? So I can easily make it as Q here. So between P and C 8 ohms, again between P and C 6 ohms, between Q and C 8 ohms, between P and Q 10 ohms. Right? Let us redraw the circuit. How many nodes are here, or how many junctions are here? 3 junctions. P, Q and C. Between P and C 8 ohms. This is over. This is P and C 6 ohms. P and C 6 ohms. This is over. Between Q and C 8 ohms. This is over. Between P and Q 10 ohms. The question is between P and Q, right? So these two are in parallel. Easily we can tell. So because these two are having common junctions or common nodes, P and Q, P and C, P and C. So 8 into 6 divided by 8 plus 6. 48 divided by 14 or 24 by 7. This combination is 24 by 7. Then this is 8, right? This circuit will be looking like this one. 10 ohms, P, Q, 8 ohms. This is 24 by 7. Right. P and Q, the question is, if a current enters P and leaves Q, one current flows through 24 by 7 and the same current flows through 8 ohms also, right? So these two are in series and 10 ohm is coming in parallel, right? So series for this value 24 by 7 plus 8, then it is in parallel with 10. That will be the answer, or PQ. 24 by 7 plus 8, then this single resistance will be coming in parallel with this 10 ohms. So what is this value? 7 into 8, 56. 56 into 24, 80. 80 by 7. Plus parallel. Parallel with 10. So RPQ is equal to 80 by 7 into 10 divided by 80 by 7 plus 10. So this is 800 by 7 divided by 7 into 10, 70. 70 plus 80 is 150. 150 by 7. 7s are removed. 800 upon 150. If you simplify it, so this is 16 by 3. 16 5s are 80, 3 5s are 15. 16 by 3 is the answer. So it is given in fraction 6 ohms. So this is 5.15 divided by 33. Yes, 5.33 ohms. 5.3 is the answer, right? 5.3 is the answer. Approximately 5.3. Next, the equivalent resistance between points A and B in the network shown in figure is between A and B. Once again, let us redraw it. We will get the answer quickly. Let us see. So only there are 3 nodes, A, B and C. A to C, 1 R. The first R. This is removed. This is B. Okay. Already I have told you this point. It's a short circuit. This is also B. This is also B. So short circuit is a junction. Between B and C, 1 R. Between B and C, another R. Between B and C, another R. 3 R's are connected between B and C. R, R, R. Between B and C. This is short circuit is a junction. So this is C. R, R, R. This is R. The question is between A and B. All the 4 R's have come here. So the equivalent value is R by 3. R divided by N, R by 3. So A and B, so this is this R comes in series with this R by 3. So this is 1 plus 1 by 3. So this is 4 by 3 R. The answer is 4 by 3 R. Option B. So next problem, 3 equal resistors R is equal to 9 ohms are joined as shown in figure. 9 ohms, 9 ohms, 9 ohms. Then equivalent resistance between A and B is what? This R, it is not in series with this R because in between another line is drawn. Similarly, this R is not in series with this R. This line is making trouble here. This R and R are not in parallel also, right? In such problems, we have to again redraw it, right? What I have told you, short circuit is a junction. This is short circuit. If A is available, along the short circuit, same potential is available. So this is also A. Whatever the potential available at this point, the same potential will be measured here, right? Similarly, this is B, this point also B, short circuit, right? Now let me remove this yellow line, right? Okay. This is A and this is B. Between A and B, R ohms connected. Between A and B, R ohms connected. Between A and B, R ohms connected. Now it is simple. Between A and B, between A and B, between A and B, R. The equivalent value will be R by 3. All are in parallel. R by 3. R is 9 ohms. So 3 will be the answer. Option D. The effective resistance between A and B is. It looks similar to the problem what we have discussed in the earlier number. If I have another resistor, so in the previous problem, instead of the short circuit, if we have another resistor, say this is R ohms, we can't make it as A here. We can't make it as B here because it is not a short circuit now, right? So this one is such a problem. It is not a short circuit here. It is not a short circuit here. This is another tip or trick I will teach here. If there are 4 nodes, please remember, and 5 resistors, 4 nodes and 5 resistors, look for Wheatstone bridge. Look for Wheatstone bridge arrangement. What is Wheatstone bridge? This is popularly called as Wheatstone bridge. This is popularly called as Wheatstone bridge, right? 5 resistor, 4 nodes, A, B, C, D, A, C, B, D, 4 nodes. It must have 4 nodes and 5 resistors, 1, 2, 3, 4, 5. Yes, 5 resistors, right? P by Q, find the ratio. This resistor, we don't know the value of it. I am writing PQRS. P by Q must be equal to the ratio. P by Q must be equal to the ratio R by S. That is the condition. P by Q must be equal to R by S. If this ratio is satisfied, this bridge is known as balanced Wheatstone bridge. This bridge is known as balanced Wheatstone bridge. For balanced Wheatstone bridge, this point is very, very important. The potential, the voltage between the junctions C and D are equal. Potential at C and D. C and D means the center arm, the two ends of the center arm. The two ends of the center arm. Potential at C and D are equal. If they are equal, no current will flow through this center resistor because the potential difference is zero. If voltage at C and voltage D are equal, potential difference is zero. If the equal potential is available, no current flows through. No current flows through it. Technically, we can remove this center resistance. Then I will have only 4 resistance P or QS. Now, after removing this resistance, if you look at the circuit, it is so simple. P and R series, Q and S series, 2 series resistance, they are in parallel. Right? So, the trick is, look at whether there are 4 nodes, A, B, C, D. Yes, 4 nodes. Point number 1. Point number 2, look at whether there are 5 resistors. 1, 2, 3, 4, 5. Yes, 5 resistor is also available in this problem. Now, find the ratio P by Q is equal to R by S. This must be satisfied. Otherwise, I can't remove the center resistance. If center resistance is available, we can't say it is a balanced Wheatstone bridge, it is unbalanced one. I will teach you how unbalanced Wheatstone bridge, it is not called Wheatstone bridge. It's a we can say it as also a Wheatstone bridge, but unbalanced Wheatstone bridge. For unbalanced Wheatstone bridge, this concept we can't use, right? Right. I will tell you what trick we can use it. Right. First, we will complete this problem. I will redraw the circuit to appear in this manner, right? Wheatstone bridge. Then only we can see whether it is satisfying the condition. Okay. Between A and B, the question is available. 5 resistors, let be formed this way: A, B, C, D. Between A and C, 2 ohms. A and C, 2 ohms. This is removed. Between C and D, 5 ohms. C and D, 5 ohms. This is removed. Between A and D, 1 ohms. A and D, 1 ohms. This is also removed. Between D and B, 2 ohms. D and B, 2 ohms. Between C and B, 4 ohms. Yes. Now we have redrawn it. It is looking like Wheatstone bridge. Next, we have to find whether it is a balanced Wheatstone bridge or unbalanced Wheatstone bridge. This ratio 2 by 1, P by Q, must be equal to the other side, 4 by 2. Yes, 2 by 1, 2, 4 by 2, 2. Balanced one. If it is a balanced one, the potential between C and D is 0. So we can remove C from the picture. Now 2 and 4 are in series, 1 and 2 are in series. The equivalent circuit will be this one: A, B, 2 and 4, 6. 1 and 2, 3. Now they are in parallel. 3 into 6 divided by 3 plus 6. 18 by 9. 2 ohm is the answer. Right. If there are 4 nodes and 5 resistance, you redraw it to make it as or to look it as a Wheatstone bridge, and you look for this condition. Okay. Now you may ask me, if Wheatstone bridge is a unbalanced one, unbalanced, say for example, it is not 2 ohms, it is 3 ohms. Then 3 by 1 is not equal to 4 by 2, unbalanced. How to solve such a circuit? It is looking like Wheatstone bridge, but it is an unbalanced one. How to solve this circuit? Connect a dummy battery. That is the concept. Connect one dummy battery. Say 10 voltage. It will send one current, I amperes. Find the value of I amperes. Because all the resistance are available. Now you can't remove 5 ohms here because it is unbalanced Wheatstone bridge. Right? You apply Kirchhoff's voltage law. Kirchhoff's voltage law. Loop number 1. This is loop number 1. Loop number 2. Loop number 3. 3 loops you need. 3 loops. Loop number 1. Loop number 2. Loop number 3. So all the resistors will be connected in your loop, in any one of the loops. If you apply Kirchhoff's voltage law and you write 3 equations, the I will be found, this current, I will be found. Then V by I will be the R equivalent. You assumed one dummy battery of 10 voltage, any value, 10 or 100 or even 1 voltage. Then for this 10 voltage, what is the current? That current V by I is equal to R equivalent. This is the answer, right? But the unbalanced Wheatstone bridge, 99% of cases, it will not come in the question paper because it is a time consuming one. It will require more time to solve this 3 loop problem, right? So we need not worry about it, unbalanced Wheatstone bridge, right? 99% of cases you will be getting only balanced Wheatstone bridge only. So you look for the condition of balanced Wheatstone bridge, 4 nodes, 5 resistors, P by Q is equal to R by S. Okay. If each resistor of the network has resistance R, then equivalent resistance between A and B. What is the equivalent resistance between A and B? If each resistor of the network R, all are having R value. So here we will solve this problem. This problem can be solved in 2 ways. In fact, 3 ways. Number 1, Wheatstone bridge. Number 2, methods of symmetry. Because all are having equal value of resistance. P by Q is equal to R by S. In the previous case, we had different values, P, Q, R, S, we had different values. But here, since it is same value, we can use methods of symmetry. In methods of symmetry, there are 2 ways, mirror symmetry and folding symmetry. For this concept, I have made a separate video. There is a separate video under the heading methods of symmetry. The link which is available in the description box. You please go and you watch it. For this method, methods of symmetry. One trick is also dealt in the topic methods of symmetry, right? mirror, that is the trick. Mirror, fold, volt. This is a trick I will use. Mirror symmetry, I will look for the currents. Folding symmetry, I will look for the voltage, right? You go and watch that video. Mirror, some rhyming is coming. Mirror, fold volt, right? But here I am not going to use this method in this problem. Let us use Wheatstone bridge. Wheatstone bridge, using Wheatstone bridge, we will solve this problem, right? These two methods are also possible. This problem, folding symmetry is also possible. Mirror symmetry is also possible, right? Let us solve this problem using Wheatstone bridge, right? How many nodes? 1, 2, 3, 4. Yes, 4 nodes. Let us name them as C and D. 4 nodes. How many resistors? 5 resistors we need, but there are 6 resistors. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 6 resistors. If 6 resistors are also available, we can apply Wheatstone bridge, right? A and B. First you remove A and B, and finally you connect A and B. Between A and B, right? That means this is our Wheatstone bridge. Between A and B, 1, 2, 3, 4, 5. Finally, you connect the 6th resistor. After solving this upper part, it will have one value. Then you connect this resistor. Yes, nothing wrong. So this problem can also be solved using Wheatstone bridge concept. That is the idea, right? Right, between here itself, let me write the values. Between A and C, this is C and this is D. A and C are, A and D are, A and C are, A and D are. B and D are, B and C are. Yes, R. C and D are also R. R by R, P by Q is equal to R by R. Yes, balanced one. So we can remove it. We can remove it. Yes, removed. 2R, 2R, they are in parallel with the removed one, this part, this final R. So actually between A and B, 3 resistors are now available. This 2R and 2R are bought from the Wheatstone bridge concept, and this is the of R, A and B. So R 1 by R AB is equal to 1 by 2R plus 1 by 2R plus 1 by R. This 2R is taken as LCM, 1 plus 1 plus 2, 4 by 2R. Then if you inverse it, 2 by 4R, that is 1 by 2R. Answer is 1 by 2R, option D. So methods of symmetry are also possible, mirror symmetry and folding symmetry. 7 resistors are connected as shown. The equivalent resistance between A and B is 1, 2, 3, 4, 5, 6, 7. Immediately we can make it as 5 ohms. 10 by 2. Right? They are in parallel. Then this 5 is not in series, neither series not parallel. Similarly, the 5 is not in series or in parallel with 8. This 3 ohms, 6 and these two are also in parallel. So the two ends, these two ends are having common node, This is also common node. So 6 and 6, 3 ohms. Immediately I can make it as 5 ohms and it as 3 ohms. Let us redraw it. From A, 5 ohms, then this is 5 ohms, this 5 ohms, then this is 8 ohms, then 3 ohms, then 3 ohms, this is B and it is the common node. This may be done. AB 10 and 10 become 5, this 6 and 6 become 3. This 3, 8, 5 are unchanged, 3, 8, 5. Then how to solve it? Once again you look for whether Wheatstone bridge arrangement is coming. A, B, 2 nodes, this is another node C, this is another node D, 4 nodes. How many resistors? 1, 2, 3, 4, 5. 5 resistors, 4 nodes, 5 resistors. You draw Wheatstone bridge. Then we will check the condition for balanced A, B, C, D. Between A and C, 5 ohms. Between A and D, 5 ohms. Between B and C, 3 ohms. Between B and D, 3 ohms. 5 by 5 is equal to 3 by 3. Between C and D, 8 ohms. Yes, this is also written here. 5 by 5 is equal to 3 by 3. Balanced. So we can remove this branch. No current flows through it. Balanced Wheatstone bridge. Now 5 plus 3, 8 ohms. 5 plus 3, 8 ohms. 8 and 8 are in parallel. 8 by 2, 4 is the answer. Option B. So redraw it. First, wherever simplification is possible, you do it. Then you redraw it. Then look for whether Wheatstone bridge arrangement is coming. If there are 4 nodes and 5 resistors, you look for it. The following circuit consists of 5 identical resistors. Each of resistance are ohms. The equivalent resistance between A and B is 1, 2, 3, 4, 5 equal values, 4 nodes. This is C and D. 4 nodes. This is A. This is B. 4 nodes, 5 resistors. So all are having equal value. Definitely it will satisfy balanced because all are having R. P by Q is equal to R by S will be R by R is equal to R by R. Definitely it will satisfy the condition of Wheatstone bridge, right? So we can draw this Wheatstone bridge arrangement. A, B, C, D. This is C, D. Between C and D, R. Between A and C, this R. Between D and B, this R. Between D and A, this R. Between C and B, this R. So balanced one, so it is removed. R plus R, 2R, R plus R, 2R. 2R is in parallel with 2R. 2R by 2 is equal to R. Option D is the answer. Right. Next problem, a uniform metallic wire has a resistance of 20 ohms. Uniform metallic wire, 20 ohm is the resistance and is bent to form a closed square. There is a wire, it is bent It is bent to form a closed square. What is the resistance across the diagonal of the square? This is a square across the diagonal. Say AB. What is the reason? Easy one. This is 20 ohms. If it is made as 4 pieces, 5 ohms, 5 ohms, 5 ohms, 5 ohms, right? R is directly proportional to the length, 5 ohms. So this will be 5, 5, 5, 5. Then A and B. So if a current I enters, it will leave B, I by 2, I by 2, two different currents. So these two are in series, these two are in series, 5 plus 5, 10, 5 plus 5, 10, 10 and 10 are in parallel. So 5 ohm is the answer, option B. A piece of wire of resistance 4 ohms is bent through 180 degree at its midpoint and the two halves are twisted together, then find the resistance. A piece of wire, its value, total value is 4 ohms. It is bent through 180 degree at its midpoint. So at midpoint means here is bent through 180 degree. It is bent. Now it is made as the two halves are made as a single wire. Twisted. They are twisted. Then find the resistance. What is this value? R dash is what? R is equal to 4 ohms. It is bent through it, right? That means the two halves will have equal values, 2 ohms and 2 ohms. Then they are bent together. The two halves are twisted together, right? Then 2 and 2, they are joined and made as a single wire. That means they are now in parallel. 2 into 2 divided by 2 plus 2. 1 ohms. 1 ohm is the answer. Right? Easy one. Next problem. A uniform wire of resistance R is stretched uniformly to n times. A wire is stretched n times and then cut to form 5 wires of equal length. 5 wires of equal length. These wires are arranged as shown. The effective resistance between A and B is what? So this is, first they are stretching it and they are cutting into 5 pieces. 5 pieces, right? This is one uniform wire. It is stretched n times. N times it is stretched. Okay, this is uniform wire. Say its resistance is R ohms. Then it is, so let me have a shorter length, right? Okay. Then it is stretched this way, n times it is stretched. So R dash is equal to n square R. This formula will be very, very useful. If you stretch it n times, the resultant, the new resistance value will be n square R, new value. We will see how it is coming, right? Actually, you are stretching the same wire. This is R. Then it is NR. Say N is equal to 2. Double the times I am stretching it. The length becomes, this is L, then this is L dash. L dash is equal to 2L. According to conservation of volume, in both cases, the volume must be same, isn't it? If you stretch it, the cross-sectional area will be coming down, right? Here it is A into L in the first case, then it is A dash into L dash. To make the right hand side also AL, what I am doing, L dash is 2L. I am stretching it. I am stretching it 2 times. Instead of L dash, I have written 2L. Then the A dash must be equal to A by 2. Then only the 2 and 2 will be getting cancelled. Both sides I will be getting AL, right? So the new value is, when you stretch the wire double the times, its cross-sectional area will be coming down by the same number. If you do it for n times, instead of 2, if I have n, right, then this is A by n and it is n into L. If it is 3, A by 3 into 3L. If it is 4, A by 4 into 4L. That is the idea. Then you find the resistance value. R dash is equal to new value I am finding, rho L dash by A dash. Old value is R is equal to rho L by A. This is old value. New value is R dash is equal to rho L dash by A dash. Rho is same because same wire, we have not changed the wire. L dash is equal to 2L. Then instead of 2L, let me write n into L, because we need in terms of n. L dash is equal to n into L. A dash is equal to A by n. This is equal to rho. This n will go up, n square L by A. Rho L by A is R. So this is n square R. The new resistance is n square R, right? R dash is equal to n square R. So this formula is very, very useful. Please learn and remember this formula, right? If you stretch one wire n times, the new value will be n square the old value, n square old value, right? What will happen if you compress it, right? If you reduce its length, n times you are compressing. So in this case, length will be reduced, cross-sectional area will be increased, right? For compressing, R dash is equal to R divided by n square. This is for stretching. This formula is for stretching. For compressing, R dash is equal to R by n square, right? Please learn and remember these two formulas. This formula you can easily prove by the same way you can do it, right? Let us go to the problem, right? This is one wire. The whole value is R. This is arrangement they are giving. A, B. R ohms stretched n times 5 wires. Actually, this is the wire, original wire. Then it is stretched. R dash is equal to n into R. N times it is stretched. N may be 2 or 3, we don't know. So R dash is equal to n square into R. The result is n square into R. Then it is cut into 5 pieces. Cut into 5 pieces. Cut to form 5 wires of equal length. So they are cutting it. So the new value is n square R by 5. 5 pieces they are making. N square R divided by 5. So equal length. Then it is formed in this way. This arrangement, right? 1, 2, 3, 4, 5, right? AB, so n square R divided by 5. This is also n square r by 5. Okay. The question is, what is the equivalent resistance between A and B? So the R value is n square r by 5. Same value, right? If you look at the arrangement, we have discussed earlier, if there are 4 nodes and 5 resistors, you look for whether Wheatstone bridge arrangement is coming. Yes, this is your Wheatstone bridge arrangement. Whether it is a balanced one or not, yes, balanced one. N square r by 5 divided by n square r by 5 is equal to this ratio, right? It is a balanced one. So in this case, no current flows through this particular branch. We can remove this branch, right? Because the potential drop is 0 here. Then n square r by 5 and this wire is in series. This is also in series. This 2 set is coming in parallel. So this is 2 into n square r by 5, first part AB. Then this is 2 into n square r by 5, this part, bottom part, right? Then the equivalent value will be equal values, so divided by 2. So RAB is equal to 2 into n square r by 5 divided by 2. The answer is n square r divided by 5. N square r divided by 5. Yes. N r by 5. This is n square r. Option C. N square r by 5. So next, a conductor of resistance 3 ohm is stretched uniformly till its length is doubled. So N is equal to 2, R is equal to 3. The wire is now bent in the form of an equilateral triangle. The new wire is formed as an equilateral triangle. The effective resistance between the ends of any side of the triangle, this is one side. What is the effective resistance? Or effective is what? So n is equal to 2, it is the length is doubled. So the new value is R dash is equal to n square or 2 square into 3, 12 ohms. 12 ohm is cut into 3 pieces, 4 ohms, 4 ohms, 4 ohms. Then any two ends, the effective resistance between the ends of any side of the triangle, right? So these two are in series, it is coming parallel. So 4 into 4 plus 4, 8 divided by 4 plus 8. It is 4 into 8 divided by 12. This is 3 and this is over. So 8 by 3 is the answer. 9 by 2, option B is correct. Here, n equal resistors are first connected in series. N equal resistors are first series and then in parallel. What is the ratio of maximum to minimum resistance? R maximum to R minimum is what? When the resistors are connected in series, the resistance value will be, the equivalent resistance value will be maximum. This is what we have learnt, right? So that is R series divided by R parallel, they are asking. R series means n value, equal value, n into R multiplied. In parallel, R by n. So this is R and R are cancelled, n square. Option C is the answer. The ratio is n square. Next, There are n similar conductors, each of resistance n conductors of R ohms. The resultant resistance comes out to be X when connected in parallel. When connected in parallel, that is R by N is equal to X. N resistors or N conductors are connected in parallel, so R by N is equal to X. If they are connected in series, then the resultant resistance will be what? If N conductors are in series, the equivalent value will be N into R. The resultant resistance will be what? So it is N into R. But in the options, there is no R available. N and X are there, right? So we have to remove R from here. So R is equal to N into X. Here, R is equal to N into X. Put R is equal to N into X. So the answer is N square X. N square X, option B. Option B is correct. Next question. A wire has a resistance of 24 ohms and it is bent in a shape shown in figure, right? This way it is bent. The effective resistance between A and C is A, B, C, D, right? It goes here and it is coming down, right? A, B, C. So R, A, C is in question. If you look at it, you can easily do it, right? Connect a battery here and trace the current direction. This is I1 and I2. I1, then this is I1 plus I2. So I1 flows 6 and 6. So they are in series. This is different current. So for this part, the 6 ohm is coming in parallel. So 6 plus 6, 12, 12 into 6. 6 plus 6 is 12. This 12 is parallel with this 6 ohms. So this is RAB. 12 into 6 divided by 12 plus 6. So 12 into 6 divided by 18. This is 3 times and this is 4. So this part is giving us 4 ohms. This part is 4 ohms. Then 4 plus 6, 10 ohms. 10 ohm is the answer. Option B. Next question. 2 wires of same metal have same length, but their cross-section area are in the ratio 3:1. Same material or metal, same length, they are in series. Cross-sectional area A1 by A2 is equal to 3:1. The resistance of the thicker wire. So thicker wire means R1. The resistance of first wire, that is thicker, 3:1, right? It is 10 ohms. The total resistance of the combination will be what? So R is equal to R1 plus R2. R1 is given as 10 ohms. We have to find using the given data what is R2, then we have to add them, right? Same metal, same length. So in such a problem, if it is same metal, that means rho same. Because we know R is equal to rho L by A. Same metal means it is rho constant, right? Same length also. Same length also. So R is proportional to 1 by A. Same metal, same length, right? So I can write R1 by R2 is equal to inversely proportional A2 by A1. A1 by A2 is 3:1. So this is 1 upon 3. R1 by R2 is equal to 1 upon 3. So R1, 3R1 is equal to R2. We need R2 first. Then we have to add. So 3 into R1, R1 is 10. So R2 is equal to 30 ohms. Now it is found. R1 is already given 10 ohms, 30 plus 10 because they are in series. So 40 ohm is the answer, option B. Next question. An electric current is passed through a circuit containing two wires of same material. Rho same. Resistivity. Connected in parallel. If the lengths and radii are in the ratio, that means L1 by L2 is equal to 4 by 3. R1 by R2 radii is equal to 2 by 3. Then the ratio of current passing through the wires will be what? I1 by I2 is equal to what? Same material connected in parallel, length ratio is given, radii ratio is given. What is the current? They are connected in parallel, right? So for parallel circuit, I is equal to V by R. This formula from Ohm's law I am writing. I is equal to V by R. For parallel circuit, voltage is constant. So I is proportional to 1 by R. Then I1 by I2 is equal to R2 by R1. R2 is rho L2 by A2. R1 is rho L1 by A1. Rho I am removing. This is giving me L2 by L1 into A1 by A2. L2 by L1 ratio is available 4 by 3 straight away. But A1 by A2 cross sectional area, radius is given. So from radius we will see what is the area. Area is equal to pi r square, or A is proportional to r square. A1 by A2 is equal to R1 by R2 the whole square, right? Let me put it here. Where? Here. I1 by I2. In this relation I am putting I1 by I2 is equal to L2 by L1 into R1 by R2 square. L2 by L1. 4 by 3, so this will be 3 by 4. Into R1 by R2, 2 by 3 square, so 4 by 9. 4 and 4, this will be 1 by 3. The answer is 1 by 3. The ratio I1 by I2. Option B, 1 by 3. Next problem. Two wires of same cross-sectional area having resistivity different. That means material different. Length also different. A same, rho different, length different, are joined in series. The equivalent resistivity of the combination is what? Right? So rho is resistivity. We have to start from this formula. R is equal to R1 plus R2. Two different materials. Don't write rho is equal to rho 1 plus rho 2. Resistivity we cannot add straight away, right? So series circuit, R is equal to R1 plus R2. Resistance, not resistivity. So R1 is equal to rho 1, L different, so L1, but cross sectional area is same, so A. Resistivity different, length different, plus rho 2 L2 by A. This R, the equivalent value rho. So when they are in series, when they are made a series, L1 and L2, right, the length becomes increased. So this is the equivalent value will be L1 plus L2 divided by A. The cross sectional area won't change, right? Cross sectional area is constant, right? A is A. So A we can remove in both the sides. So rho L1 plus L2 is equal to rho 1 L1 plus rho 2 L2. So we need rho. Rho is equal to rho 1 L1 plus rho 2 L2 divided by cross multiplying, we are getting L1 plus L2 in the denominator. Rho 1 L1 plus rho 2 L2 by L1 plus L2. Option A. Here it is rho 1 L2. It is rho 1 L2. This is minus sign. This is minus sign, yes. So option A is right. Rho 1 L1 plus rho 2 L2 divided by L1 plus L2. Right. If sigma 1, sigma 2 and sigma 3 are the conductances of 3 conductors, then their equivalent conductance when they are joined in series will be what? Series connection conductances, they are given equivalent value, right? Sigma, actually sigma is conductivity, not conductance, but they are asking us to assume if sigma 1, sigma 2, sigma 3 are the conductances. So we will take, right? Actually R is equal to 1 by G. Conductance is written as G, right? Rho is equal to 1 by sigma. Resistivity is the inverse of conductivity. Sigma is conductivity. But here they are asking us to assume conductance itself, right? So we can write R is equal to 1 by G is equal to 1 by sigma. This is according to this statement, this can be okay. R is equal to 1 by sigma, right? Theoretically, rho is equal to 1 by sigma, right? So the question is 3 conductors, their conductivities or conductances, then their equivalent conductance when they are joined in series. So as I told, we must start from R only. R is equal to R1 plus R2 plus R3. We should not start from sigma or rho, right? R is equal to R1 plus R2 plus R3 series. Then what is R? R is equal to 1 by sigma is equal to 1 by sigma 1 plus 1 by sigma 2 plus 1 by sigma 3, right? Then this is sigma 1, sigma 2, sigma 3. This is sigma 2, sigma 3 plus sigma 1, sigma 3 plus sigma 1, sigma 2. This is 1 by sigma. We need equivalent conductance. That is sigma we need. So sigma is equal to again reciprocal, again inverse. That is, let me write here. Sigma is equal to, take the inverse. Sigma 1, sigma 2, sigma 3 divided by sigma 2, sigma 3 plus sigma 1, sigma 3 plus sigma 1, sigma 2. That is the answer. Sigma 1, option A is wrong. Sigma 1, sigma 2, sigma 3 divided by sigma 1 plus sigma 2 plus sigma 3. C is also wrong. B 1 by sigma 1, B is also wrong. None of this is the right answer, right? So none of these could be the right answer. So here none of this. This answer is not printed in the options given. So none of these. Next problem. Two resistors R1 and R2 provide series to parallel combination as N. R series divided by R parallel. This is N. Then the current relationship is what? Two resistors are given, R1 and R2. If they are connected in series, for R series, we will write R1 plus R2. For parallel, we will write R1, R2 divided by R1 plus R2. This is for parallel, which is equal to N. R1 plus R2 I can take to the top. So R1 plus R2 square divided by R1, R2. This is N. What is the current relationship? Right hand side, N is there. N square, N power 3 by 2, N power 1 by 2. N is equal to R1 by R2 plus R2 by R1. But here it is different value. So option C will not be the correct answer. So we will square both sides. We will check whether A is correct. Right? If I square both sides, this will be R1 plus R2 power 4. R1 plus R2 power 4 divided by R1 R2 square is equal to N square. Then N square it is also not correct. Option A is also not correct. Right? If we take N power of taking square root for this equation, R1 plus R2 square divided by R1 R2 N. This is the result we have obtained. If I square it, it will be R1 plus R2 only. Then this is square root. Then this is square root. R1 R2, the square we have removed R1 R2 under square. N is also under square. This is, so we can simplify it. Let us check and simplify it. R1 plus R2. First, let us split them. R1 divided by square root of R1 R2 plus R2 divided by square root of R1 R2. This is root N. I am splitting it as two terms. Then one R1 I can remove. Here R1 by R2. One R1 I am removing under the square. Then here R2 I can remove. So under the square R2 plus R1 is equal to root N. This is R1 R2 power of plus R2 by R1 power of, and right hand side is N power of. Option D is correct answer. Right. Next question. Two wires of same dimensions. That means L and A constant. Resistivities are different. Two wires, row and row 2, they are in series. Connection is in series. The equivalent resistivity, rho is equal to what? So as I told you, you should not start from rho is equal to rho 1 plus rho 2. That is wrong. We have to start from R is equal to R1 plus R2. From this formula only we have to start. Right? R is equal to, so first let me write here, R1 is equal to rho 1, different resistivity, same dimensions. So L by A is same. Rho 2, L by A is same. Here rho, they are connected in series connection. So when it is connected in series, the length will be increasing, same length. So this will be L plus L, 2L. Cross sectional area won't change. Yes. Then L by A, both sides we can remove. 2 rho is equal to rho 1 plus rho 2. Rho is equal to rho 1 plus rho 2 divided by 2. Option, no, this is wrong. C is wrong. Yeah. Half of rho 1 plus rho 2. Option B is right. Rho 1 plus rho 2 by 2. Next question. N conducting wires. N conducting wires, but different same dimensions, different resistivity, rho different, their values are given as rho value 1, 2, 3, N conducting wires up to. That means rho value of first conductor is 1, rho value of next conductor is 2, rho value of third conductor is 3, this way. They are in series connection. The equivalent resistivity of the combination is what? They are in series. What is the rho equivalent? Rho 1, rho 2, rho 3. This way we cannot write. N conducting wires, same dimensions, right? So N means N can be chosen any value. Let us assume in such problems, let us fix one N value, right? So it is easy for us to fix one N value and to find rho value, and this N value and rho value are matching the options given, right? Let N is equal to say 3. You assume. Let N is equal to 3, right? That means I am having only 3 wires. So the equivalent R value will be R1 plus R2 plus R3. This is rho, same dimensions. So 3L divided by A, right? 3 times it is increasing. N is equal to 3, only 3 wires are you are having. So L, 3L, cross sectional area is not changing. A, R1 is equal to rho 1 L by A plus rho 2 L by A plus rho 3 L by A. This rho 1, rho 2, rho 3 are given as 1, 2, 3, right? 3. The left hand side it is 3 rho L by A, 3 rho L by A, rho 1 is 1, so L by A only, plus 2 L by A plus 3 L by A. L by A we can remove both sides. So 3 rho is equal to L by A we are removing. L by A, L by A, L by A, L by A. So 3 rho is equal to here 1 is available, 1 plus 2 plus 3. So this is 6, 3 rho. So rho is equal to 6 by 3, 2. So this is one set. If N is equal to 3, rho is equal to 2. If N is equal to 3, rho is equal to 2. Let us check. Let us substitute the value. Rho value is given. The equivalent values are given. Substitute N is equal to 3 in all the options and to find which option is giving us rho is equal to 2. Right? First I am putting here. N is equal to 3. 3 into 3 plus 1. 4 divided by 2. 3 plus 1 is 4. So 2, 4. So this is 6. I need 2 as answer. So here N is equal to 3. 3 plus 1 divided by 2 into 3. 4 by 6. 2 by 3. This is wrong. Option B, N plus 1 by 2. N is equal to 3. 3 plus 1 by 2. 4 by 2 is equal to 2. Rho is equal to 2. Yes, this is correct. Option B is correct. D also we will check. 2 into 3, 6. 6 divided by 4. 6 divided by 4. This is coming as 6 divided by 4. This will not be the correct answer. This way we can arrive at the right option, right? So for n is equal to 4 also we will, let me check what is row value for n is equal to 4. If n is equal to 4, here it will be 4, 1 plus 2 plus 3 plus 4. For n is equal to 4, this side will be row L by A, row is equal to 4. So this is 4 row is equal to 1 plus 2 plus 3 plus 4. So this is 10. So row is equal to 2.5. N is equal to 4, we must check whether row is equal to 2.5. If n is equal to 4, row must be 2.5. Let us put here in the correct option. N is equal to 4, 4 plus 1, 5, 5 divided by 2, 2.5. Yes. So the option B is correct. Next question. Find the equivalent resistance between the points A and B in the infinite ladder network. Infinite ladder network shown in figure. So this circuit is extended up to infinity. 1 ohms, 2 ohms, 1 ohms, 2 ohms. It is going infinity times, it is repeated. 1 ohms, 2 ohms. This is one pair. In the ladder, different rungs are available. Rungs, steps in the ladder. So similarly, some set is available. It is formed such that it is going, it is extended up to infinity. What will be the equivalent resistance between A and B, right? So the question is, what is RAB for infinity is what? Infinity ladder network, right? So we know the concept is to solve such problems, infinity minus 1 is equal to infinity. This is the idea we are going to use here. Any number which is operated with infinity, we know infinity will be the result. Infinity plus 1 is equal to infinity. Similarly, infinity minus 1 is also infinity. This is the idea we are going to use, right? Let me take it in the next page, right? This is R of infinity network. Let us assume the answer is going to be X. X is the answer. Finally, we are going to find what is the value of X, right? Here, infinity rungs are available or the set is available. Let me break here. Let me break the entire circuit at this point. I am separating the two circuits. Only one ladder, only one rung I am taking here. The entire part I am removing. I am separating them from the circuit. So this is infinity minus 1 set is available up to infinity. It is extended up to infinity, right? So this is, if you consider this part also, this is infinity. This is infinity, right? This is up to infinity, it is extended, right? So we know infinity minus 1 is equal to also infinity. If I assume R of infinity is equal to X, at this point, let me label it as CD. At this point also, the resistance of this part is also infinity. So R of infinity minus 1 is also X. If R of infinity is X, R of infinity minus 1 should also be X. That is the idea we are going to use, right? Mathematically it is true. R of infinity is X, so R of infinity minus 1 is also X, right? So I can redraw the circuit as A this is 1 ohms, then this is B, this is 2 ohms, and this point is C and this point is D. C and D. This part R of infinity minus 1 also x ohms. We have shown here. R of infinity is also x ohms. This is also x. X, x. This is x. R of infinity minus 1 is also x. Now this x and 2 are in parallel. For this parallel combination, 1 is coming in series. Right. So RAB we need, RAB is equal to x. We have assumed this 2 into x are in parallel, 2x divided by 2 plus x. R1 R2 divided by R1 plus R2 plus this 1 ohms. So x is equal to 2x divided by 2 plus x divided by 2 plus x, which is equal to, cross multiplying it, 2x plus x square is equal to 2x, sorry, this is 3x, 2x plus x, 3x plus 2. So x square minus x, 3x is coming to left hand side, x, this will be minus 2 is equal to 0. Minus 2 also I am taking to left hand side, x square, 3x minus 2x, x minus 2 is coming to left hand side. This is one quadratic equation. Power 2, power 1 constant. Ax square plus bx plus c is equal to 0. So minus b plus or minus, this formula we can use to find the value of x. Minus b plus or minus b square minus 4ac divided by 2a. This is x. So minus b is minus 1. So I will write plus 1 plus or minus b square is 1 minus 4ac, c is 2. So this will be plus 4 into a into c. So 4 into 1 into c is 2. 8 divided by 2, right? So 1 plus 8, this is root 9. Root 9 is 3. So this will be 1 plus or minus 3 divided by 2. X is equal to. So plus or minus, two answers we can write. X is equal to 1 plus 3 by 2, 4 by 2. Or x is equal to 1 minus 3 by 2, minus 2 by 2, this is minus 1. So x can be 2 or x can be minus 1. This answer we should not take it. So resistance value, equivalent resistance value cannot be negative value. So x is equal to 2 is the right answer. X is equal to 2, option B. Option B is correct. A cube has resistance R between any two opposite faces. A cube has resistance R between any two opposite faces. Okay. Cube has resistance R between any two faces, right? If the cube is split into 27 identical cubes, if it is split into 27 identical cubes between opposite faces of the small cube, one small cube we have removed. So 27 means it is 27 is equal to 3 cube. So 3 lines I can draw. Line 1, line 2, right? How it is cut into 27 cubes, right? This way they are cutting it. This way they are cutting it. So one small cube is formed, right? Small cube, let me draw here. This is a small cube. This is a big cube. Then the resistance between opposite faces of the small cube is what? What will be the resistance of the small cube? Any two faces you can consider, because all are having same dimensions. All the sides are equal in cube, right? I assume this is a dimension related problem. No current data, no power data or voltage data is given, only dimension related problem. This formula we will use. R is equal to rho L by A, right? Length and area we have to find. For the bigger cube, what is the length and what is the area? For the smaller cube, what is the length and the area? We have to compare it. That is the idea, right? Let me assume this is x unit, some length. So all the sides are x. Then it is 3 pieces. So this will be x by 3. The side of the bigger cube is x, if you assume it, then it should be x by 3, right? So here R big, rho L by A, R small, rho L dash by A dash. This is rho L is equal to x and A is equal to x square, isn't it? X into x is cross sectional area. So this is rho by x, R big, rho by x. R small is rho L dash is x by 3 divided by A dash is x by 3 into x by 3. X by 3. So x by 3 and 1 x by 3 we can remove. The 3 will go up, 3 rho by x. This is R small. R small is 3 rho by x. R big is rho by x, right? So if we relate them, R small is equal to 3 times of R big. R big is R. So this will be 3 rho by x is 3R. 3 times it is increasing. Option A is correct. So only the dimensions, how the length is changing and how the area is changing. Next problem, a block has dimensions 1 centimeter, 2 centimeter and 3 centimeter. This is also dimension related problem. Ratio of maximum resistance to minimum resistance between any 2 points on opposite faces of the block is what? Ratio of maximum to minimum. This is in question. The dimensions are given 1 centimeter, 2 centimeter and 3 centimeter. So definitely this will be 3 centimeter. This should be 2 centimeter and 1 centimeter this side. 1 centimeter, 2 centimeter, 3 centimeter. Okay. To get maximum resistance, what is the formula? R is equal to rho L by A. R is directly proportional to L. If you want higher resistance, the length of the conductor must be a longer one. So for maximum resistance, we have to make L is equal to 3. L is equal to 3. If you make L is equal to 3 centimeter, then the cross-sectional area will be this part. This is the cross-sectional area, right? For maximum resistance, L must be 3 and A must be the other 2. 1 into 2. Yes, 2 centimeter square. Isn't it? So you are connecting the two wires in this way. So the current is flowing in this direction from top to bottom. This way if you connect it, then this is coming as cross sectional area, right? L and A. For minimum resistance, for R minimum, the L must be the minimum one, 1 centimeter. So you have to connect the battery this way. The current must be flowing the left hand side to right hand side, right? So L is 1 centimeter, then area is equal to others 2 into 3, 6 centimeters square. Then we can easily find the ratio. Rho is constant because material we have not changed it. So R is proportional to L by A. R is proportional to L by A only. So R maximum divided by R minimum, L by A divided by L dash by A dash. This is L dash and A dash. So L by A, L is 3 divided by 2. Then here L dash is 1 divided by A dash is 6. This can be made as 3 into 3, 9, 9 by 1. The answer is 9:1. Option A is correct. Next question. A tetrahedral means it is having 4 sides. Side 1, side 2, side 3 and the rear side, 4 sides of 6 identical wires. 1, 2, 3, 4, 5, 6 as shown in the figure. Each wire is having a resistance of 2 ohms. So this is 2 ohms, 2 ohms. All are having 2 ohms, 2 ohms, 2 ohms. When an ideal cell of EMF 2 voltage, ideal cell of EMF 2 voltage, ideal cell means it doesn't have any internal resistance, connected across AB as shown, then the current through CD is what? This is CD, branch CD. What is the current flowing through this branch? It is in the question. All are having 2 ohms. So already I have told you, if you have 4 nodes A, B, C, D, 4 nodes or 4 junctions and 5 resistances, you look for whether Wheatstone bridge arrangement is existing. 1, 2, 3, 4, 5, it is 6, 1, 2, 3, 4, 5, 6 resistances. A and B also 1 resistance it is given, right? So let us redraw it and verify whether Wheatstone bridge arrangement is coming, right? This is A and B, CD. Between A and B, 2 ohms. A and B, it is 2 ohms. Between A and C, 2 ohms. Between A and D, 2 ohms. Between B and C, 2 ohms. Between B and D, it's B and D, 2 ohms. Between C and D, 2 ohms. Between A and B, the voltage, battery. This is A and this is B. So actually for Wheatstone bridge arrangement, this is enough. Between A and B, the battery is given. Across this battery, one more resistance is also here. So 6 identical wires, 6 resistance. We have studied if 5 resistance are enough, for forming the Wheatstone bridge? Yes. A and C 2 ohms. A and C, this 2 ohm. Then A and D, this 2 ohms. Then C and D, these 2 ohms. Then C and B, these 2 ohms. Then D and B, these 2 ohms. Then A and B, these 2 ohms. Across the battery, these 2 ohms. So this is a balanced one, balanced Wheatstone bridge. The question is, what is the current through CD? Current through CD is 0 because it is a balanced one. No matter how much voltage you are giving here, no matter how many resistors are connected in parallel with this battery, the current will be always 0 because this part is a Wheatstone bridge, a balanced Wheatstone bridge. So the answer is option D, 0. Option D, 0. Right. Next question. Two statements are given. The equivalent resistance in series combination is larger than even the largest individual resistance. Yes, true. Series connection, in series combination, the equivalent will be higher than the larger individual resistance. Statement 2, the equivalent resistance of the parallel combination is smaller than even the smallest. So bigger than the largest, smaller than the smallest for parallel connection. For parallel, it is smaller, the smallest. True. In series, larger than the largest. This is also true. Both are true. If statement 1 is true, if statement 1 is true, statement 2 is true, statement 2 is correct explanation of statement 1. No. Statement 2 is not explaining it. Both the statements are independent. They don't have any connection. So this will not be the correct answer. So B, if statement 1 is true, statement 2 is true, statement 2 is not correct explanation of statement 1. No need, right? If statement 1 is true, statement 2 is false. If statement 1 is false, statement 2 is true, right? Statement 2 is not correct explanation of statement 1. B is correct. Both the statements are independent, right? Both the statements are independent. If statement 1 is true, statement 2 is true, statement 2 is not correct explanation of statement 1. Statement 2 need not explain statement 1. So this is the right option, right? Right. Then some part of problems, they are dealt in a separate video. Methods of symmetry. Symmetrical networks. Methods of symmetry is not included in this video. It is dealt separately in a separate video. That is mirror symmetry and folding symmetry. Some problems we have worked in that video. Please go and watch that video also. The link is given in the description box. All the best. Thank you for watching it. Right.